Hello, this is the Screencast assignment number 2, done by Armando J. Macias. We'll first be talking about supertypes and subtype relations. So, a supertype is an entity that has got a relationship, a parent or child relationship, with one or more subtypes, and it contains attributes that are common to subtypes. Subtypes are subgroups of the supertype entity and have unique attributes, but they will also be different from any other subtype. An example of this is here's a supertype, bird. These are the subtypes, duck, cuckoo, and ostrich. They are all different from each other, but they're all subtypes of birds because they fall under the bird category. Also, we have attribute inheritance, which indicates whether processes in the class should be automatically reclassified when one of the classification attributes of the process change. So if something changes in one entity, when one attribute changes, let's say like the age or the income level, any subtype that relates to those attributes will inherit the different changes. We have also a completeness constraint, which addresses the issues of whether or not an occurrence of a supertype must also have a corresponding subtype occurrence. Also, we have total specialization rule, which specifies that an occurrence of a supertype must also have a corresponding subtype occurrence. And now we have partial specialization rule, which specifies that an entity instance of a supertype is not allowed to belong to any subtype. So the completeness constraint basically states whether or not a supertype needs to have a subtype depending on how it's used and the relations to the other one. The rule for total specialization specifies that it does have a supertype must have a subtype for the corresponding occurrence. So if something needs to be recalled in the supertype, it must have a subtype. The partial specialization rule means that you can have a supertype, but it doesn't need to have any subtypes. So you can have automobile, but you don't have to have any of the automobile makers, like the brands or anything that you will use as a subtype. Now we have the disjointness constraint, which is a constraint that addresses the questions of whether or not an instance of a supertype may simultaneously be a member of two or more subtypes. Then we also have the disjoint rule, which specifies that if an entity instance of the supertype is a member of one supertype, it cannot simultaneously be a member of any other supertype. And then at the end we have an overlap rule, which specifies that an entity of an instance can simultaneously be a member of two or more subtypes. So here we have the disjointness constraint. I will have examples a bit further on about this. So it basically states that it puts a rule to the supertypes that they have to have two or more subtypes. They cannot have one. So these are supertypes that have various attributes that may be needed in the model. The disjoint rule says basically only one subtype to each supertype. So you cannot have, in the example that we gave above, we couldn't have an ostrich and a cuckoo because they will both fall under the bird supertype. So we can only choose whether to have one or the other. Overlap rule, though, specifies that an instance can have simultaneously be a member of two or more subtypes. So essentially, an overlap rule means that the attributes can overlap. So they're both birds and they both have long legs. So they can both overlap in the same constraint. Now we have a subtype discriminators, which are attributes of the supertype whose values determine the target subtype or subtypes. So basically, for this one, we have whether or not a subtype can belong to other subtypes or can relate to them based on the subtype. Like if an example that we gave above, you cannot have birds, and the discriminators, it will be birds, for example. So we have the ostrich, the cuckoo, and the duck. So here we have the bird, the duck, the cuckoo, and ostrich. If we have another subtypes of dog, of cat, we cannot mix them with these because that's the discriminators that we are choosing for it. So here's the disjoint rule. It's one of the harder ones to understand. So here we have guitar. Then it goes to disjoint, and we have electric and non-electric. So these disjoints are two different types, and they don't overlap. They each have their own attributes. The non-electric basically has a hollow body and has different strings. And electric may have different strength and has a solid body. Secondly, we go with the relation data model. The relation is the way in which two or more concepts, objects, or people are connected, a thing effect on or relevance to another. So we have purchase number 1. Here we have the relation between John, books.example.com, Lenny the Lion, birthday gift, and $15. So these all relate because these are related to the purchase. So all these entities relate to each other. Now we're going to the keys. The primary key is an attribute or combination of attributes that uniquely identifies each row in a relation. A composite key is a primary key that consists of two or more than an attribute. Foreign keys, an attribute in a relation of a database that serves as a primary key of another relation in the database. I have a few examples right now to help you understand this better. Here we have the primary key, which is underlined, which is the social security number of the student master. Here we have the two private keys, which will become the composite, because here we have private key is a semester and private key unique. Here we would have the last key, which is the foreign key. As you see here, its own private key uses the foreign key number 1 social security number from here, and here the foreign key will be semester, using it from here, and unique. So as you see, this one has 2 foreign keys, although it uses 3. Also here we have the composite. Here we have the 2 primary keys for this row, which are product ID and vendor ID. These determine how it affects each of the rows. Here we have entity integrity, which is no primary key attribute or components of a primary key attribute can be null. That means that they must always have a value. And referential integrity, it's the rule that states that either each foreign key value must match a primary key value in the other relation, or else the foreign key must be null. So referential integrity, if you are using this method of integrity to refer to any other entity or its attribute, it must have a value or a primary key to relate to it, or else the foreign key is empty or null. Also here we have the normalization, which in functional dependency, it's a constraint between 2 attributes or 2 sets of attributes. We also have partial functional dependency, which is a functional dependency in which one or more non-key attributes, such as name, are functionally dependent on part but not all of the primary key. Lastly, we have transitive dependency. It's a functional dependency between 2 or more non-key attributes. I will have an explanation between this later on. Lastly, we have the first normal forms, a relation which constrains no multi-value attributes. The second normal form is a relation that is the first normal form and has every non-key attribute fully functionally dependent on the primary key. The third normal form is a relation that is in second normal form and has no transitive dependence. Let's go back to the normalization first. Functional dependency, it's the function of each attribute depends on a different attribute. Here we have 2 or more attributes depend on each other. So you have 2 sets or 2 pairs of attributes depending on each other. This can be current age depending on date of birth, or you could have current residence with the city. Partial dependency is that it only depends partially on either the primary key or any other attributes that are not being affected as the primary key. The transitive dependency is depending on 2 or more non-key attributes. So you would not need the product key for the primary key, foreign key, or composite key for these. You would have to be like age, name, or anything like that you would need, but you would not use as a primary key or foreign key. Now, lastly, let's go to our examples. So here we have unnormalized form UNF. It's to create a model. The first normal form, we are removing repeating attributes. So we want to keep only single value attributes. We do not want to keep repeating each of the same ones in every single entity. The second pass is a second normal form, which removes partial dependencies. So we want them to be integral. So for that, we don't need them to depend on each other. Last one, we have the third normal form, which will remove transitive dependencies. So here we want each of them to depend on themselves and not depend on each other. So that concludes my presentation on the second screencast. Thank you very much.